Alright, starting with number 1, approximate each number using a calculator round to 3 decimal places. This is saying 5 to the exponent 3.4, not 3 times 4, 3.4. And so on your calculator you do 5 and then this exponent button and then type in 3.4. When you press enter, it should give you the answer. And if we want 3 decimal places, that is 237.957. And that's all there is to that one. On 2 and 3, we're making a couple graphs with tables of values or tables of coordinates. And so what you do is you set up an x and a y table. We're going to pick -2, -1, 0, 1, and 2 on both of these. And all we do is we take whatever this is and we plug in those numbers. So we're going to do, sorry, I don't know why I just wrote 5. We're going to do 4 to the -2 and plug that into our calculator for exponent -2. And it tells us that that is 0.625. And then we do 4 to the -1 and it tells us that is 0.25. 4 to the 0 is 1, 4 to the 1 is 4, and 4 to the 2 is 16. And this is going to give us an idea of what our graph should look like if we graph these points. So -2 and then 0.0625 is about right there. -1, 0.25 is just a little bit above that, right there. And then 0, 1. And then 1, 4. And then sadly 216 is not on this graph, so we'll just leave it off. This goes down and to the left. This goes up and to the right. And it doesn't actually cross the x-axis, it just gets closer and closer until it can't get any closer. So here we have 1/2 to the x. So in your calculator you would do 1 divided by 2, raise it to the -2 by using the exponent button, and then press enter. So that would give us 4, and then you keep plugging in each value. So that's 2, 1, 0.5, and 0.25. And then we graph each of these points. So -2, 4, -1, 2, 0, 1, 1, 0.5, and 2, 0.25. So we go down and to the right and up and to the left. As far as formulas go for your blue sheet, I'm okay with you writing here what these letters mean. So P is the money that you're putting in. P for putting. So money you're putting in. R is the interest rate, and make sure you change that to a decimal. T is the number of years. And the thing that's difficult about these is N. N is how many times will you get money in 1 year. And I know that's kind of wordy, but to me that's the easiest way of thinking about it, is to ask yourself that. So P is 1600 in this problem. R is 0.08 when you change the percent to a decimal. T is 2 years, and then compounded quarterly, that's what's telling us how many times in a year we're going to get money. If I told you, hey, I'm going to give you money, I'm going to pay you quarterly, how often am I going to pay you in 1 year? I'm going to pay you 4 times. So that tells us that N is 4. If we have an N, that means we're going to use this formula up here. And so we plug it in. And the key thing is on this, when you plug it into the calculator, you're going to have to put 4 times 2 in parentheses. Like you're going to do this is how I type it out. 1600 open parentheses 1 plus 0.08 divided by 4 close parentheses, exponent button parentheses 4 times 2 close parentheses. When you do that, you get I'm having to type it in, so okay, so I get 1874.66. I'm rounding the 2 decimal places because we're talking about money, and just think about it, that's how many decimal places there are for money. The other situation we can have here, compounded continuously, think of it like this. If I said, hey, I'm going to continuously give you money throughout this year, continuously. How many times in a year am I going to give you money? Well, we can't say something like 12 or 4, because I'm going to keep giving you money like all the time. And so in a way, we could almost say that n would be like infinity, because I'm just going to give you money like every second of every day. Well, because of that, we're going to use the formula that doesn't have n, this a equals p ETRT. You do that whenever it's compounded continuously. So a equals 1000 e to the r, which is 0.09, times t, which is 6. Remember that the e button is on your calculator. You do second ln, and it's 0.09 times 6. Again, that exponent needs to be in parentheses, but your calculator should put the open parentheses for you. When you press the E button, it should do E to the and give you an open parentheses, or just make it look like an exponent, depending on what kind of calculator you have. So this is 1716.01. That's our answer. Composition. So that's where we put functions together. So we always plug in backwards. So I start at the right here and I plug into G. So I'm going to take a 4 and put it into G. So that gives me 4 plus 2, which is 6. But I'm not done. I'm going to take that answer, 6, and plug it into F. So 6 squared plus 3 times 6. You can plug that into the calculator or do it by hand. And either way, you should get 54. On this one, now if it has x as the farthest thing to the right, we really don't have to plug that in, because look, if I plug an x into F, it already has an x there. So that part doesn't really matter. What we want to do is take F and plug it into G. So I'm going to pick up F, which is 6x plus 6. I'm going to drag it over here and put it right here where that x is, so that that x is no longer there. Now what's there instead is 6x plus 6. Which means that I have 6x plus 6 plus 5, add like terms, and get 6x plus 11, and that's my answer. Here, we're doing G into F, and so I'm going to take 7x minus 9 and put it in here where x is, and so that means I'm going to have square root of 7x minus 9 plus 5, and so you add like terms under your square root, and get 7x minus 4. That does not simplify. Don't make that some kind of a 2 situation. It doesn't work like that. Just leave it alone. Leave it be. These instructions actually help you out as to what to do. You're trying to find f of g of x and g of f of x. So let's start there. F of g of x means take g and plug it into f. So I'm going to take x over 8 and put it right here where this x is. So that's 8 times x over 8. Well, this is like 8 over 1 times x over 8, so the 8's cancel and leave me with x. If I do this both directions and I get x both times, that means these functions are inverses of each other. So now I'm going to take 8x and put it right here where x is on top. So that's 8x over 8. Again, the 8's cancel and I get x. So my answer to this is yes, they are inverses. So on this next one, we'll get to see what happens when they're not inverses. We do f of g of x, so take 4x minus 8, put it where this x is. So, like so, and then simplify on top. -8 plus -8 is -16. Pay attention to those signs, they're important. if I try to simplify this, what's happening is as long as I can divide both numbers on top by 4, I can. So that's 1x, which is just x, minus 4. But now I'm done simplifying. I can't do anything else, but I don't have just x. I have x minus 4. So this is no, they are not inverses. Now we're going to find the inverse. And so to do that, the first thing we do is we change the f of x to y. We switch the x and the y around. And then we solve. So in order to solve this, we're going to have to add 4 and then divide by -6. So that gives me x plus 4 equals -6y, divide by -6. And so the way we write this is we write f of -1 of x. That means f inverse, which we started with f, this is the inverse, equals x plus 4 over -6. And you may be like, oh wow, do I have to remember to put exactly that? Well, it's going to be a multiple choice question, so they'll put it on there for you in a nice sort of way. So 12, put a y there, change the x and the y. And to get y by itself here, we want to get rid of this cube, so we cube root both sides. So that gives me the cube root of x equals y minus 3. So I add 3 to both sides and get f inverse of x equals the cube root of x plus 3. Now notice I didn't put the plus 3 underneath the cube root sign because I took the cube root of x and then I added 3. So that 3 does not go underneath. Okay, a formula you might think about putting, or a couple of formulas, if you haven't already put these on there, you might think about it, that we have logarithmic form, which is log with a little b, y equals x. And we have exponential form, which is b to the x equals y. And I may have, when I wrote it on the board, switched the y and the x around. But what matters here is that if you're given something in logarithmic form, you can change it to exponential form by rearranging in this way that I've shown. And so here, if we look at what our formula is, then we know that b is 3, y is 9, x is 2, and then we can rewrite it in exponential form. So 3 to the second power equals 9. And that's all it wants us to do is write it. It doesn't want us to simplify that at all. It's just that's our answer. And if you don't need to write all that out, that's fine. That's just, if you don't understand how to get it, that's how you go about it. So here, our formula b to the, this is exponential form, and we want to change it to logarithmic form. So here, b is 3, x is -2, and y is 1/9. So we're putting it in logarithmic form. So you write log 3 1/9 equals -2. We wrote down a whole bunch of properties from 9.3 and 9.4, and so now is where we start using them. On the first column, I think it's D. There is a property that says b to the log bx equals x. What's important here is if these numbers match, the thing down here and the base of our logarithm, then basically they're canceling each other out and leaving us with x. And so here, the sixes are the same, so all of this is going to go away, and it's going to leave us with just 19, because that's what x would be in this case. Now we're going to do some expanding, and so we have properties written down for this. This is the product rule, and like I said, we're expanding, so there's a certain set of rules for that. The reason I know it's a product rule is because I'm multiplying, and so the product rule says, hey, split these up into two different logarithms where you are adding between them. Then check to see if you can simplify, In order to simplify, like, these numbers would have to be the same. Like, we'd have to have a log base 2 of 2, or maybe like a log base 2 of 8, which we could then change to be 2 to some power. But what we have right now, we can't simplify, so that's just our answer. Here we have a quotient right here. And so what we're going to do is we're going to split that up into subtraction. Log base 7 of 7 minus log base 7 of x. That's what the quotient rule tells us to do. And so now we got to check to see if we can simplify it. Well, log base 7 of 7 is 1. If those numbers match, okay, exactly, and there's no exponent here, which there really is a 1 if there's not 1 written there, then we just make it 1, and then it's still minus log 7 of x. Still trying to expand here, so this is another quotient. Even though it's natural log, the same rules apply. So natural log e squared minus natural log of 5. Well, natural log of e will always just cancel each other out and leave us with our exponent. So this is 2 minus the natural log of 5. 19 is kind of complicated. On top, that's one too many. Oh, snap. Well, if you didn't have that written down, just go back and write it. Rewind the video and pause it. Okay, so on this one, we have a product on top, and so that means I'm going to split up that product into addition. But we also have something we're dividing by, which is a quotient. So we're going to subtract the part we are dividing by. So now each thing up here, the x, the y, and the z, they each got their own logarithm. The other thing we can do when we expand is we can move the power in front of our logarithm. And that's it. That's our answer right there. Now we're going to condense, and so we're trying to make them into one single logarithm. So here I'm subtracting, which means it's the quotient rule. When I put them together, I divide. 162 divided by 2. But wait, we can figure out what that is. 162 divided by 2 is 81. Then it'd be nice if we could rewrite this as 3 to some power. 81 is 3 to some power. So let's check. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. Oh, look, 3 to the fourth power is 81, which means I would put a 4 here. Log base 3 of 3 cancels out, and our answer is just 4. 21, subtraction, so I change it to a quotient. And then I'm done. I can't actually simplify that any further. 22, we want to first start using the power rule to make this y to the 8th and z to the 7th. That makes them not be in front anymore. Then we look at the fact that this is a plus sign to change it to multiplication. Y to the 8th times z to the 7th. Use common logarithms. So if it asks you to put it in your calculator, there's a formula for that goes something like this. Log base n of m equals log of m over log of n. So it's the second number over the first number. So here we're going to do log of 4 divided by log 6. And in your calculator, it opens parentheses for you when you press log. So you have to close it and then divide by log, open parentheses 6. So I gotta pull out my calculator and do that real quick. I get 0.7737. It asks us for 4 decimal places, so naturally we should oblige. And this one is log 71.2. divided by log 15. Then you get 1.5751. Now let's start solving some equations. So this actually gives you a hint. Solve the equation by expressing each side as a power of the same base. So this base is 4, so we want to rewrite 64 as 4 to some unknown power. So we got to check and see, okay, 4 to the first power is 4. 4 to the second power is 16. 4 to the third power is 64. Bingo! So 4 to the negative x equals 4 to the third. Well, if these are the same, we can get rid of the bases and just say negative x equals 3, which if we divide by negative 1 on both sides to solve for x means that x equals negative 3. On 26, 2 to the 3x minus 7 equals 4. Well, I want to try to rewrite 4 as 2 to some power. And 4 happens to be 2 squared. So once I do that, I get rid of these bottom 2's, our bases, and get 3x minus 7 equals 2. Add 7 to both sides. You get 3x equals 9. Divide by 3. You get x equals 3 for your answer. Solve the exponential equation by taking the logarithm on both sides. When it says that, it's talking about either the regular logarithm or the natural logarithm. On this first one, it'd be beneficial for us to use the natural logarithm because we know that natural log of e goes away and it would leave us with just 2x. Once we know that 2x equals the natural log of 5, that means we just need to divide by 2 on both sides. And on our calculator, that's ln, it opens a parentheses, 5, close parentheses, and then divide by 2. Which is 0.8047. This one's a little bit more tricky, more complicated on 28, so it doesn't matter if you take the regular log or the natural log. So if I take the regular log of 3 to the 8x equals 2.8, then, well, sorry, I have to take the log of both sides, right? So I'm taking the log of both sides, so that means I need log of 2.8 on the right. Well, I'm allowed to use the power rule to move the 8x in front of my logarithm, so that I have 8x log of 3 equals log of 2.8. Well, in order to get x by itself, what I need to do is divide by 8 and by log 3. Which means x equals, and when you do this, put the bottom in parentheses. So you're going to type into your calculator log of 2.8 divided by open parentheses, because we're starting the bottom of a fraction where we've got more than one thing. So let me type that in. It gives you 0.1171 for x. Last two. So if we have a logarithm, the way to go is to rewrite this as an exponential equation. So we wrote a formula earlier about how to go from logarithmic form to exponential form. So what we do is we start with the 2, and then the exponent is the 5, and it equals x. So in this case, all I have to do is figure out what 2 to the 5th power is. It's 32. And that's our answer. On this one, I rewrite in exponential form. So I start with 8 to the 4th equals x squared. I can find 8 to the 4th by putting it into a calculator, but I know I'm about to square root, so I'm going to just do that all at once. Remember, if you're solving an equation and you take the square root, you have to put a plus or minus. And if I type in square root of 8 to the 4th, I end up with 64. And that's all there is to it, folks.